Hello and welcome. This is the AQA AS Unit 2 June 2013 past paper. Now this is question 7, which is the last question on the paper. Okay, so what we're given is that this is this laser being shone through this single slit. Now I've drawn it in drawn it in red light and it should have been blue, so I do apologise. Let me just change that to not confuse you. Okay, so this is laser shining out blue light, not the red that I drew on there, so I do apologise. Okay, so it's shining onto through this single slit, and it's shining onto this screen. Okay, so standard kind of screen, single slit screen, and we get this intensity pattern. Now both of these, as I said, are given to you in the paper, but I've just drawn them there for simplicity. Now, the first question, part A, well, actually doesn't show that. It's just a simple a 1-mark question. It says, state what monochromatic light is. Okay, well, let's break it down in case if it doesn't jump at you straight away. Okay, well, mono means one. And the only thing that light is made up of, because it's monochromatic light, so whatever chromatic means, obviously, not going to have too much of an effect on this. Okay, so if there's anything that's light and to do with it being one of light, well, the only thing that light's made up of photons, so monochromatic light therefore must be one photon, and therefore it's one frequency. Okay, try to build up to that. It's just a light of one frequency, or therefore a light of one wavelength, because we know wavelength C equals F lambda. Okay, so you can rearrange that, but essentially it's just a light of one frequency or one wavelength. Okay. Now, I know it's not really related to this question, but the other thing that I found difficult, now I don't know if it's for you, as I said, it only took me a little mention, as opposed to a big one. Okay, so the other thing that I kind of messed up on was something called coherent sources. Now, the difference between monochromatic light and coherent sources, because they are kind of related in this kind of thing, coherent sources is light of the same potential difference and the same frequency. Okay, so a coherent source is the same potential difference and the same frequency. Okay, so that's a laser is a coherent source of light. That's why we can afford to put a laser just through a single slit, because at the point of it, the first single slit is to split it up into 2 coherent sources. Okay, and that's why we've got a light. We've already got a laser that's already a coherent source. Okay, so we don't need to split it up again. Makes some kind of sense. Alright, so anyway, that's what monochromatic light is, and coherent source. Right, so now we're showing this intensity graph. And the laser is replaced by a laser emitting red light. So I jumped ahead of myself before, as you can see. On the axis for figure 9, sketch the intensity graph for a laser emitting red light. Okay, now for this we have to think about the electromagnetic spectrum. Sorry, the actual wavelengths in terms of what colours have what wavelengths. Okay, so if you look up the wavelength for red light, you should find it is different to the wavelength of blue light. Now, as I said, it's something you can do in your own time, but it might help you. It doesn't necessarily help you to explain this. Okay. So basically, I'm going to draw it on there in a minute, but just read out what the mark scheme wants you to draw on. Okay, so it's a subsidiary maxima, centre of peaks away further from the centre. Okay, so basically we've got a wider peak, and it needs to be symmetrical. Okay, so subsidiary maxa, which is peaks further away from the centre, which essentially saying it's wider, and then the central maximum is twice the width of the other maximums, which is generally what we see. Okay, and the central maximum, and it should be symmetrical. Okay, so that's what it is. Alright, so what we're looking at is just a slightly wider graph on here, okay, with slightly higher maximums. Okay, so I'll probably better draw it in a different colour. Red will probably be more appropriate. So this is a red light. Basically, all it is just higher intensity, something like this, and a wider maximum. Okay, so you could just write over the top something like that. Okay, so please do correct me if you think that is incorrect, but that's, I mean, I've read out the point, so you should be able to get the idea from that. Okay, so that's 7B. 7C says state what and explain one precaution that should be taken when using laser light. Now, the main precaution that I mention is the easiest to mention is don't look directly at it. And that's because it's a one frequency, it's very concentrated and very powerful. That's why you see a single point, because it's a single wavelength, so it's direct at a point. Okay, so obviously, you know, that could mess up your eyes a little bit. Okay, but the other answers that they would have accepted, okay, great. I've accidentally closed the mark screen down on my computer. I don't know why, but you know, a bit weird like that. Okay, so let me get back to 7. Okay, right. They would have accepted avoid reflections, wear safety goggles, put warnings on that the laser's on, stand behind the lens. Laser, and just generally any other sensible suggestions. Basically ones that don't imply you looking straight at it or pointing it at someone else. Okay, so you know, it's kind of logical, that question, really. Alright, so 7D, the red laser light is replaced by a non-laser source emitting white light. Explain how the appearance of the patterns would change. Now, the white light, you've got to remember, it's made up of many different wavelengths. Okay, so what we experience when we put it on the screen is, I'll just draw, I mean, I can't really do much with this, but basically we get some kind of a rainbow pattern. Now, they don't allow you to say rainbow colours. You have to specifically mention that there's a rainbow pattern if you are going to talk about the rainbow. And if you're not sure what I mean, I can't really draw it out because I don't have the colours for it. But you can look on in the AQA book, or just type in rainbow pattern for a white light being shown through a single slit on Google Images. I'm sure it'll come up. But you just need, obviously you don't need to be able to draw that, you just need to mention that, okay? And they've labelled 4 points on here, and they said you've got to have at least 3 of them. So obviously, because all the colours focus on the centre, okay, they all come to a maximum at the centre, they all superimpose at the centre, is the right word, we get this central white fringe, okay? And I kind of mentioned there's 2 marks there by saying, you know, every, all subsidiary marks will compose at the centre, okay? And as we get towards the end, we start seeing the red and the blue. Obviously, you can relate that to the wavelengths and stuff, okay? So, 3 marks I would pick, okay? So, the central white fringe, because all the subsidiary maxima are imposed at the middle, okay? We have a rainbow pattern, okay, which is allowed instead of a spectrum, which I think is a lot easier to say. So, basically, we white in the middle, we've got a central white fringe, but they do say they allow white in the middle, which is the same thing, obviously, but because they put it at the side and not as a main point, it probably doesn't look as good if you just say white in the middle. It's always better to put the points they have listed. Okay, so central white fringe, there's a rainbow pattern towards the outside in terms of you go from the violet to the blue to the red, and the red is the furthest away from the centre. Okay, so there's 3 points so far, and then you just mentioned towards the end that the fringe spacing is less than for the white one than the red, because the maxima are wider, which is basically the difference between the 2 heights. When I say difference between the 2 heights, this is point and point. These distances here are greater for the white light because the fringes are smaller or not present. Okay. It does say you're allowed a full credit for an annotated sketch, but it doesn't list it on here. I don't want to kind of guess, because when I do the exams, I tend not to draw a sketch because we've already drawn a sketch on there, and it just wastes extra time. Okay, it's easier just to pick one of them points that we've listed. Now, if you didn't get, I did kind of rush 7D a little bit, but all the points are listed on the mark scheme, as you can tell. So please do check the mark scheme out if anything I've missed out, because mainly this question is kind of bullet pointed. It just took a bit of explaining for some of the parts of this question. Okay, so thanks for watching, and hopefully to some degree it's been enjoyable. I always put in the description, hope you've enjoyed the video, and I'm not doing that because I'm insane or want to kill a few more hours doing revision, typing in enjoy the video when nobody reads the description anyway, just for my benefit. Okay, so thanks for watching, and we'll see you in the next video. whenever that may be, or whatever it is.